Everyone, in this video we're going to be solving a cubic equation with radicals. We have x cubed minus 3x equals 10 times the square root of 2, and we're going to be solving for x values. I'll be presenting two methods, and let's start with the first one. So for my first method, I'm going to use the cubic formula. To be able to use the cubic formula, first of all, I'm going to consider the identity. Basically, by using this identity, you can come up with the cubic formula. And if we apply it to our equation, we notice the following. First of all, we have x cubed minus 3x on the left and 10 root 2 on the right. So what we need to do is replace a plus b with x and then compare the coefficients. The coefficient of x is negative 3 and the coefficient of x here is negative 3ab. So we're going to set negative 3ab equal to negative 3, which implies that ab is equal to 1. And then we're going to set the constant equal to 10 root 2. So we're going to get a cubed plus b cubed equals 10 root 2. By solving this system, we're going to be able to find the values of a and b, which then will be plugged into x equals a plus b. So the sum of a and b, and they're interchangeable, by the way, from symmetry, is going to give us the value of x, and then so on and so forth. Okay, let's get to work. So to be able to solve the system, I'm going to cube the first equation. A cubed b cubed equals 1. And a cubed plus b cubed is equal to 10 root 2. Now, if you're able to find two numbers whose product is 1 and whose sum is 10 root 2, go ahead right away and find it. If you can't find them right away, then you need to solve a quadratic formula. Let me show you how the quadratic formula is solved, but finding the numbers is not that hard in this case either. Let me show you some tricks. Okay, so if you go ahead and isolate one of these, for example, from the second equation, I can isolate b cubed and then substitute that into the first one, and that's going to give me a cubed times 10 root 2 minus a cubed equals 1. And then if you set a cubed equal to c, then you'll get a quadratic equation, because this is going to become 10 root 2c minus c squared equals 1, and then c squared minus 10 root 2 plus 1 is equal to 0. So this is kind of funny, because we were talking about two numbers whose product is 1 and whose sum is 10 root 2. This is exactly, by Vieta's formulas, the equation that satisfies those conditions. Okay, now you can think about it this way. To find the values of c, I can kind of think of it this way, and I believe Portian Low made a video on this method, even though this method has been known. And I made a video on the same method, which I referred you to his page and so on and so forth. But anyways, there's a method that kind of uses the following. So what is the opposite of the, by the way, I forgot to write the c here. Here we go. What is the opposite of the coefficient of c here? It's 10 root 2. So we're going to cut that in half. That's going to give us 5 root 2. So I'm going to assume that my numbers are going to be like 5 root 2 plus something and 5 root 2 minus something. So in other words, they're kind of conjugates, but their product needs to be 1. In this case, if you square this number, you get 50. So you basically need a 7 here, because when you multiply these from difference of two squares, you get 50 minus 49, which is equal to 1. So that satisfies the Vieta's formulas. I hope this makes sense. If you don't like this, go ahead and use the quadratic formula, and you'll find the exact same values. So those are the c values. So one of the c values is 5 root 2 plus 7, and I can take that to be a cubed. So from here, a becomes the cube root of 5 root 2 plus 7. And then the other c value, I can set the b cubed. Again, those values are interchangeable. Doesn't matter, because their sum is going to make up x. Remember that? So x is going to become the cube root of 5 root 2 plus 7 plus the cube root of 5 root 2 minus 7. Notice that these are conjugates. Of course, their cube roots are also conjugates. Therefore, when they're added, some terms are going to cancel out, so on and so forth. The $1 million question is, what is the cube root of 5 root 2 plus 7? And what is the cube root of 5 root 2 minus 7? And if you can find out one of these, obviously the other one is going to be conjugate. So let's focus on this first. What is this equal to, right? Well, there's a long process, and this probably deserves another video, and I probably made a video on something like this. I don't know if I can find it, but you guys are better at finding those videos because I have too many videos. And if you've recently seen it, anyways, I can tell you quickly what this is gonna be like. So if you cube root 2 plus 1, and it's kind of like thin air, but you're gonna get 5 root 2 plus 7. Let me just give it to you real quick, okay, to keep a long story short. So in other words, the cube root of 5 root 2 plus 7 is exactly root 2 plus 1. Therefore, the cube root of 5 root 2 minus 7 is square root of 2 minus 1. So their sum is going to give us x, and x is going to be 2 root 2. Great. That's it? Well, yeah, we got to do a lot of work, but that's basically what it is. It's a very long method, I do know that, but I want to show you an alternative. So this is the cubic formula. That's how you use it. Sometimes you don't get a nice result, because what if I ask you to find the cube root of 7 root 2 minus 5? It would probably not be a nice thing to do. I was trying to generalize this like the square roots. There's a formula, but anyways, that's pretty hard, and if I do, I'll let you know. So let's go ahead and take a look at the second method. And the second method obviously is much, much better. But the motivation behind using the cubic formula for this problem was the presence of x cubed minus 3x equals a constant. So x squared is missing. That's nice. And this, I can directly apply it, even though it's a long method. Now, the second method is better, obviously. So I'm going to assume that my x, and you know that from the first method, but just pretend you haven't seen it, is going to be a multiple of root 2. So I'm assuming that x is something like a root 2, where a is an integer or a rational number. It's probably an integer, right? So let's go ahead and replace x with a root 2. If you cube it, x cubed is going to be a cubed times 2 root 2, which is 2a cubed root 2. And then you're going to get the following from here: 2a cubed root 2 minus 3 times x, 3a root 2. And that's going to equal 10 root 2. Make sense? Cool. Now we're going to go ahead and divide everything by root 2, because that's a common factor. And we're going to end up with a nicer cubic equation. Obviously, it's much nicer than the first one, because at least we don't have any radicals. And we can use the rational root theorem, right? Well, you could do that, or you can actually make this monic. Monic means the coefficient of a is, or a cubed is 1. And you can do the following: multiply by 4 both sides, and then write this as 2a cubed, and write this as 2a squared times 3 equals 40, and then replace 2a with something. How about set 2a equal to t? That gives you t cubed minus 3t squared equals 40, right? And then what I need to do is from here, excuse me, I do need to, actually I messed up here. Let me go ahead and fix it real quick. This is not squared. This is just 3a, so that needs to be multiplied by 6, not 3. Okay, there you go. So it's going to look like this, and then obviously that's going to change my t equation as well. So it's going to be t cubed minus 6t is equal to 40. Now, you can apply rational root theorem. So we're basically looking at factors of 40. And if you write it in this form, it's going to be a little easier to guess. And I'm guessing t equals 4 is going to work, because 64 is 40 plus 24. Makes sense? Okay, t equals 4 is the solution, but t is 2a. 2a equals 4. Therefore, a is equal to 2. Makes sense? But what is a, right? Okay, so a is, x is a root 2. So since a is 2, x is going to be 2 root 2. All right? That's basically what this is all about. And this brings us to the graph. There you go. We have a cubic function that kind of curves so that it can have, 3 solutions, one of which is 0, obviously. But it intersects the horizontal line y equals 10 root 2 at exactly x equals 2 root 2. So that's the only real solution. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.